Okay. We'll continue now with schools, Maria.
Okay, thank you.
Vaivula Vlasmeni is an important municipality near the center of Athens. We have buildings, so it is very important for us to have this project because our buildings we are visible for the young people. The implementation of the project was in very satisfied level. Maria, who is old colleague in grants, has very experience in the EA grants. So Maria, give us more technical information about the project.
Dear all, I'm very happy being with you at the premises of the National Energy Operator here in Iceland. It is a real honor representing the municipality of Tsarmpopoulou Maria. The municipality is located at the suburban Tsarmpopoulou region at the southeast part of Athens. Today we have prepared on behalf of the Technical Services Division a short presentation in order to introduce you the key elements of the proposal being funded by the European Economic Area Mechanism, GR Energy 2014-2021. As you can see on the first slide, the project is entitled Energy Upgrades and Installation in Municipal Buildings of Tsarmpopoulou Maria. The project was co-financed up to the amount of approximately 1.3 million euros. And at the bottom of the slide, you can see the logo we used during the dissemination campaign, working together for a green energy. Basically, the proposal which was submitted to the thematic area of energy security and renewable energy sources, it basically reflects a strong eagerness of the municipality board of members to implement a holistic energy plan in order to transform the city into a smart, eco-friendly community. Thus, the municipality cooperates into several European and national consortia seeking for funding, and we try to apply the basic elements of the smart city, like the climate neutral cities, the urban mobility schemes, and so on. Moving quickly into the core element, to the core presentation. After the closure of the project, we delivered 7 energy efficient municipal buildings, which were 5 school buildings, the building of technical services, and the social services building. The core scope of this project was the amelioration of the thermal and optical conditions and comfort for the end users, along with the energy costs saved during the entire life cycle of the building. In rough lines, the technical works being performed was the thermal insulation, the installation of PV panels, the installation of thermal units, along with the replacement of all lighting system with the one of LED technology, and finally a horizontal action, the measuring and recording equipment in order to better reflect and monitor the energy behavior of the building after the end of the work. The eligible period finished the April of 2024. Along you can see the total eligible amount up to 1.3 million euros. The project was basically divided into 4 individual projects. The first one had to do with the thermal insulation of the terrace of 2 buildings in order to prevent the heating and the humidity entering into the interior of the building. The second one had to do with the procurement and supply of new electromechanical equipment, and the other two individual projects had to do with advisory services on the dissemination campaign and advisory services on how to better select the proper equipment. These are in very detailed way the energy upgrading actions. I just moving on. As you can see, project results in number. 1,085 lighting systems were replaced by 739 lighting systems of LED. We've managed to achieve about 30% of energy saved due to this replacement. 907 kilowatt of thermal power by the installation of heating pumps. We've managed to replace the petroleum and the old system of heating to schools, offering also this comfort to the student community. 181 kilowatts from the first year of operation due to the installation of PV panels. We've managed, because we monitor these systems, we've managed to achieve at least we covered all the needs of the school buildings during the winter period thanks to this installation of PV panels. And we have this integrated system which provides us the control in case of emergency conditions, in order for the technical services division to go to move to correction actions. The expected benefits is that we try to capitalize our knowledge achieved and experience to other municipalities and to other bodies. That's why we seek for cooperations, and we are glad to say that we have ameliorated the energy carbon footprint of the city. The strengths of this project, the first one was the fruitful cooperation with press. We are very glad to have you supervising us. Thank you, Marcos, thank you, Kostas, thank you, Vasilia, and of course, Eli. Thank you, we are very grateful because we've managed to get all the amount proposed for the municipality and transferred it into a concrete result, energy result. Thank you so much. And the weakness is it is a kind of proposal in case of a new call. We would like to share our experience with you after the weaknesses we suffered. The estimated benefits in numbers, you can see that we have significant things to show in terms of numbers, because we estimate and we think and we will see in the near future that we will have all our school buildings working individually without being able to cover all their own needs due to the PV installation panels and the thermal units being used. This is a typical EPC, as the mayor said before. This is the certificate, it is a typical certificate. You can see that it is from the school of the Gymnasium Vari. From this EPC, we can see that we've managed, and this in the matrix, you can see all the 7 buildings being transformed. You can see that we've managed to upgrade to categories, to high energy categories, the buildings we selected. All 7 buildings are now. You can see the 3rd column. This is the after the energy auditing results. You can see that all selected buildings, and the most important, the school buildings, are classified to high energy categories, A and A+, meaning that they can stand without needing any energy from HEDNO, the Hellenic Energy operator, and we are glad for that. We've managed to go better, to go further than the scenarios, the best scenarios we had in mind before the start of works, before the granting. This is some screenshots I took just to show you how this monitoring and energy management system works. You can see when the PV panels start to work. We have summarized the daily production, the annual production, and we can monitor if all the systems are working okay. This is from the technical services building, these screenshots. And this is the dissemination material which was produced during this phase. We are very proud because all this material was produced by recycled paper, and we're very glad, and we are very grateful to Kres and Eli also, who gave us the directions to do something correct. We've managed to produce a lot of leaflets, braille leaflets also for the people with disabilities, and notebooks, and 2 press releases. We had an open day where we presented the results of the project with a lot of citizens being in the audience. It was I want to say that it was a project that went very public, and we are glad for that, because the citizens show a lot of interest, not only the citizens, also the school community. It went very well. And some photos during the implementation phase. You can see the ranking of cables, the installation of PVs, the ladder lights replacements, and these are the results after the completion of works. You can see the dissemination, which is the dissemination plates to all 7 buildings. The heat pumps, these are the internal units. I'm showing the photos clockwise. The new LED lights, the heat pumps, the external units, the monitoring of the equipment, and the PV panels on top of buildings. And the monitoring, also the inverters, which we always check the daily and month production. And this is the building. Thank you very much for your attention.
Thank you, Maria.
Thank you too, Kostas.
Ευχαριστούμε, κύριε Δημάρχη. Because you mentioned something critical, that there was a difficulty in connecting the photovoltaics.
Yes.
Can you just very briefly?
Basically, we had to face the problem that we had first to get licensed by the HEDNO, the Hellenic Energy Distribution Operator.
Metering, isn't it?
Yes, they are all smart metered. But we had to take first the license, and this took us a lot, the procedure, I mean. And then we had to cover the fees for this license. We had to cover on our side the fees for that case. But the most important thing, not only the expenses, okay, this was covered, but the difficult was about 2 months procedure, and we were afraid to connect the new load, the new production, to the metering equipment of the consumption, because now we are obliged to have 2 metering equipment, the one from the production coming from photovoltaics, and the other coming to monitor the consumption from the output. And this was the angle.
2 months delay for connecting.
Yes. And it's in some case because we wanted to increase the capacity of the load due to thermal heating equipment, more than that, maybe 3 months.
Because you had to upgrade.
Yes, to upgrade to another category. Yes.
The network. Okay, this is a very
critical, yes, thing.
This is difficult. That's why, because I had the discussion with the director, why these programs. And I mentioned it's useful that you mentioned that you did something like that, but
it took us time. So the experience that I would like to share with you is that into a next project we have to start very early these procedures in order to be ready when the installation comes to connect directly to the grid.
Okay. So that's the next phase.
No, everything is settled now. We are having our equipment working and we monitor them, but it was a stressful situation the 1 year before.
Because you have to close everything within the programming period.
Exactly.
And it was this kind of delays. This is an experience for us also as program operators to know the reality and not theoretically. Because if you want to cooperate with the Hellenic distribution network operator that is responsible for connecting the photovoltaics to the network, you have to take into account these delays that are out of control. So, because the programming period was ending, and you cannot justify anything when the period is end, they had and I understand it was very stressful to push everything and everything to be, because after that crisis is checking if the installation is working, and it's, you know, very.
This sounds like a very common problem for everyone who's setting up solar in Greece.
Yes, because network is really the problem of the network is really very, very critical, not only for the photovoltaics, but even for wind connect and all this kind of thing.
You know, we have a quite old network system, and that's why we always have to check on the stability of the network. And this is where the head node interferes and has to control everything, that everything will go okay after new loads, because all these are new loads for the old system, and we have to be very careful as a municipality, as a monitoring body like CRES.
Because a school is even the cables of the old system are really not appropriate in order to host this photovoltaic power, and this is a small, let's say, picture of the big problem in Greece, that if you want to achieve targets for renewables, you have to focus in parallel in 2 points.
Exactly.
The renewable energy equipment, but also networks. And if the government does not see this in parallel, we have a problem. Network is very critical for the from a school to the whole system of Greece.
This is a common problem to every project.
To every project, yes.